Let us discuss this example. So in this example, we have a matrix space XD and A is any subset of X. We have to prove that these two sets are equal. So generally, how to prove two sets are equal? We prove that one set is subset of other. After that, we prove that second set is subset of first set, and then we say both of them are equal. So I'm going to use the same technique here. Let us take one point from the first set. Let X belongs to X minus A bar. I'm going to prove that X belongs to second set. Then we can declare the first set is subset of second set. Okay. You remember the definition of limit point. The definition of limit point is BXR minus singleton X intersection A is not equal to phi. This is definition of limit point. If this definition is satisfied, we can declare X is a limit point of A. If you remove this part from this definition, then we get a definition of point of a closure set. Getting? Then we can declare X belongs to A bar, closure of A. Getting? So see, here we have a same kind of thing. X belongs to X minus A bar. That means X belongs to closure of X minus A. So therefore I can write, therefore BXR intersection X minus A is not equal to phi for all r greater than 0. Let me remove this part. It is not required now. See what it means. It means every open ball with center X intersects complement of X minus A. I will show you in a diagram. So this is matrix space XD. This is set A. If X is here, if X is here, if you draw any ball around X, 100% that ball intersects some part of complement of A. So it intersects X minus A. So that means same thing I can write. Therefore, BXR, any open ball cannot be subset of A, for all are greater than 0. So if you draw any ball around X, it cannot be a subset of A. It will go outside A. So therefore, X is not an interior point of A. So we get thing exactly opposite to definition of interior point. So that's why I can say X is not an interior point of A. In definition of interior point, what we get? BXR subset of A. Getting na? So we are getting BXR is not subset of A, and this is true for all R. So that's why it is not an interior point. So that means X does not belongs to A interior. So X does not belong to A interior. That means X belongs to its complement. If any person is not present in Ratnagiri, that means it is outside the Ratnagiri. It is in complement. So therefore X belongs to X minus A interior. We had taken point from X minus A bar, and we are proving that it is in X minus A interior. So therefore what can we say? Therefore X minus A bar is subset of X minus A interior. So I will call it as 1. So here we have proved that 1 is subset of other. Similarly, I am going to prove second is subset of first. Make a screenshot of it, then we will go further. So now I am taking point from X minus A interior. So X lies in complement of A interior. So therefore, what can we say? X does not belongs to A interior. So that means I will show you. So suppose this is A interior, and X belongs to its complement. So that's why X does not belongs to A interior. X does not belongs to A interior. That means X is not an interior point of A. So it is not an interior point of A. What is definition of interior point for A? There exists R greater than 0 such that BXR subset of A. We are getting it is not an interior point. That means exactly opposite definition we supposed to write. So exactly opposite definition means what? So therefore I should write for every R greater than 0. For every R greater than 0, Bxr is not a subset of A. In definition of interior point, we write it is subset of A, but here we are getting it is not an interior point, so that's why it is not a subset of A. So it is not a subset of A, that means it intersects its complement. Therefore, Bxr intersects complement, that is x minus a is not equal to 5. I will show you here. Suppose this is set A. Suppose x is here, getting, and if you draw any ball around x, it is not a subset of A. That means this ball intersects its complement, getting, and this is true for every r, for all r greater than 0, since we have mentioned for every r greater than 0. So therefore, so this is definition of closure set, getting now. So therefore, x belongs to closure of x minus a. Since x minus a is there, this is definition of closure point, getting. If you write minus x, bxr minus singleton x, and if you write the same definition, this is definition of limit point. But if you have simply bxr intersection x minus a, this is definition of closure point. So x belongs to x minus a bar. So it's a closure point of x minus a. We had taken point from x minus a interior and we are proving it is in x minus a bar. So therefore, what can we say? X minus a interior subset of x minus a bar. So this is 2. So in one we have proved one is subset of other, and in second we are proving say other is subset of first set. So from 1 and 2, what we get? X minus a bar is equal to x minus a interior. So in this way we have completed this example. Make a screenshot of it, then we will stop. Thank you. Bye bye.